Welcome to a new part of the ISM Statistics 1 exercise set, this time with an exercise on measures of dispersion. Let's take a closer look at the exercise. Calculate using the following classified datasets the corresponding corrected sample variance and sample standard deviation. Here we have the first one and the second one. Let's work our way through those two exercises step by step. Let's start with part A. We consider the first table. And first off, we need the arithmetic mean. The arithmetic mean for classified data we get by calculating the class means and multiplying the class means with the relative frequencies. Alternatively, multiplying with the absolute frequencies and dividing by their sum, which in the end is the same as multiplying with the relative frequencies. If we do this, we get here as a result 60.7287. With this arithmetic mean, we can get the corrected sample variance via the following formula. This might look relatively strange. What did we actually do here? We did the same as with non-classified data. We go there, we take our class means, we square them, multiply them with the absolute frequencies. That's, for example, for the first time, the absolute frequency is 31. The class mean for the first class is 24.5. So here we have 31 times 24.5 to the power of 2. We do this for all the 5 classes. Then we divide this by n, by the number of observations. Therefore, I said we could also have multiplied this with the relative frequencies. And then we go minus arithmetic mean to the power of 2, or here arithmetic mean times arithmetic mean. The result, this is the part here in the big brackets and big parentheses, is multiplied with n divided by n minus 1. So here number of observations in total is 187, and we divide this by 1 less, so 186. This gets us from the normal variance to the corrected sample variance. And in the end, we get a result of 360.0359, having our sample variance. Okay, we were asked to have the sample variance. We also were asked to get the standard deviation, the corrected standard deviation. So I have to do this as well. However, this is relatively easily done. We just take the sample variance and take the root. And here we get the root of approximately 360 is 18.9746, concluding this first part of the exercise. For the second part, we basically do the same stuff over again. We consider our table, and from the table we calculate the arithmetic mean. Again, we multiply the class averages with the absolute frequencies and divide this by the overall number of observations. Or, alternatively, as done here in the example, we can directly multiply the class means with the relative frequencies. Whatever you decide on, in the end you will get an arithmetic mean of 239.9625. This we can then, again as with the first example, use to get the corrected sample variance. Again, we multiply absolute frequencies with the squared class averages. Do this for all the 5 classes. Divide this durch the number of observations. So here 169 minus the squared arithmetic mean. To get from this theoretical variance to the sample variance, we multiply this then with 169 divided by 168. And in the end, we will get results for this sample variance of 4018.4 4198. Okay, so far so good. Only one step to go, and that's to get to the corrected standard deviation. However, this is relatively easily done. We just take the sample variance, take the square root, and have our result. So here the square of the variance gets us a value of 63.391, which then is our sample standard deviation. And well, this then concludes part B, and therefore the whole exercise. I hope that all of you enjoyed listening to this exercise and learned at least something from it. And well, until next time, see you and goodbye.